My bad, I'm not all set up. I just got back from work. But let me try this. Okay. Let me know when you could see the CodeQuest site. All right. Well, it should be up. But basically, Justin, you'll go to this site, create an account. And then once you're in, let's see, I think you go to My Classes, and then you'll click Join Class. And then I have a code for you. When you click Join Class, you'll just paste that in there and should be good to go. I think everybody should have at least one. Yeah, most of you guys, but so should be good to go. Any other questions? That was basically it. And then just to try there's like a hello world problem just to get set up. And it sounds like we're going to be, or your teacher asked me to go through using Python. So that's what we'll be using, which fortunately for me, because I haven't used Java in a long time. So I think this will be much easier to go through. But all right. Yeah, so basically every time you're presented a problem, everybody's first instinct is to always like just start coding, but you'll save so much time in the long run if you like create an outline. It doesn't have to be like formal or anything. It could just be like jot down some notes, ideas, like pseudocode or even some drawings, just to make sure that you know what you're doing and like have thought through the problem, because there will be many times where like I'll be working on a problem and you just think of things like halfway through and then you have to like change the way you've coded something. But if you like thoroughly thought through the problem, you'll like have like a pretty solid understanding of what to code, and like the coding will be much easier. And I forget the exact breakdown, but I think most of the time you spend like in this whole like solving a problem process is like mainly debugging your code. The coding part is usually not the longest. So you can save yourself a lot of headaches by not diving into the coding immediately. And so parts of the outline that, or like areas that I think about before I like start coding is like, what are my inputs and outputs? Like, what am I receiving? And like, what am I like expected to return? And a big one is edge cases. Like, how will my code work at like either like really big input, small input, or like at the edges of your like any like sort of loops or stuff. Just making sure you think about that, because that's typically where a lot of errors occur. And then I would like jot down like maybe like a pseudo code of your algorithm, like I guess kind of similar to like the English version of your code at a very high level, just to make sure everything makes sense. And then any like data structures, variables you're going to use, it makes a big difference, like how you store your data, because that affects how you search your data, and it could really affect your like how efficient your code is. And then functions, like really looking for reusability. A big thing, like if you're like retyping the same code over or like copy and pasting stuff and just changing names, like you're probably doing something wrong. Always try to look for like being able to reuse code to make things more efficient, so that you don't have to write things over and over again. And because really the more code you write, the more chances for errors. And it's just easier to debug, and easier for somebody else to come and look at your code if everything's like well organized. The next step, implementing the code, is pretty straightforward. I think the more practice you get at coding, you'll just get more comfortable. And there's no problem with like not knowing things. Like I just Google like a lot of common things over and over again, because there's no reason to like memorize a lot of stuff. But I think as long as you have like a solid like process of how to approach a problem, I think you'll be fine. You don't have to worry too much about like a lot of small nitty-gritty details. The third bullet, testing. Testing is very important. I think what I know you guys said you guys were using Eclipse for Java, but what will you be using to code and for Python?
I think normally a lot of us use like VS Code. I don't want to
Okay,
speak for everyone, but yeah.
perfect. Thank you. So yeah, I know the CodeQuest Academy, you kind of just put your script in and then it'll like spit out if you passed or not and what you failed. But making sure you test your own code, writing your own test cases, or even taking the sample input and then kind of expanding on the test cases they give you, just to make sure that your code would like be like passing for a lot of different scenarios. We can go over that a little later. And debugging, it's a pain, but it's something you'll have to get used to. And hopefully like the more time you put before coding your like writing your code, then you'll save time debugging. And then documentation is not too big of a deal for our purposes now, but it's just something to think about, that even just writing some comments for your future self or somebody who would work on your code in the future is really important. I think programmers in general don't like to document, but it's really hard to get into like a new code base, or say like you have to make a change to somebody's program. And most of the times I'll look at something and have no idea what they're going for. So using like good variable names, good function names, and then good comments are really helpful, especially in the future if you want to like go over these problems we go over. And so you can try them again and get an understanding for what you did. This picture on the top right is like a route up a mountain. There's many paths to take up the mountain, just like how in a lot of these problems we'll look at, there's going to be many possible solutions. Some are better than others, and there are trade-offs. So I think I'll try and give you guys some tools to think about like what makes different algorithms better or worse, and kind of how to like quantify how good your approaches are. But at the end of the day, your first goal should be making sure that we get up the mountain, like finding a path that works, and then we could worry about how well it is after. And then down here is some of the basic data types for Python. Your classic strings, numbers like integers, floats, all kind of fall on under one. Lists and tuples, tuples, however you want to call it, they're pretty nice. A lot of these, what I like about the Python data types is that you can interchange variables. Like you can have a variable be a string, and then it could become a number or another data type. It's not I forget the exact term, but in other languages, like once you initialize a variable to a certain type, you can't change its type. And making use of dictionaries and sets when you can are very important. They can really improve your runtime of your code if you can use them wisely. And we'll try and go over some examples. But yeah, that's kind of a high level overview, and then I have a practice problem we can try go through if this is any questions here. Alrighty. Let's see. So this is just a sample problem. I'm not sure if it's in the code quest, but basically the problem here is to create a routine or like a function. Oh, hello. Oh, was somebody talking?
I think someone just came into the Zoom meeting and just didn't mute their mic.
Okay, cool.
Yeah.
All right. So this problem is to basically create a routine that takes in a string and returns true if the string has all unique characters and false otherwise. So here's a couple examples. Like this would be like your sample input and output. So if you had this routine check unique and you received this string, it would be true because there's all the characters are unique. But in this case, there's two A's, so you return false. And so I'll let you guys think about this for a couple minutes, try to think of like an outline and how you would approach this problem. Then we can go over it together in like, I'll give you guys like 2 minutes. Yeah, the language doesn't really matter. I mean, as long as I'm really more worried about like how you think about the problem and the algorithm, and then debugging the code shouldn't be too bad. It's all right. So for this problem, the first thing I would think about is what my inputs are. So I know my inputs are a string. Oh, can't type. Our output is a Boolean. And some of our edge cases, like it's always good to check that your input is valid. So I would do like is the input valid, like empty, the type, is it a string, stuff like that. And so I guess this is kind of going into our check unique function that takes in a some string. So first thing would be checking that the input is valid. And then the next thing would be like, and if it's invalid, we would return. Basically return false. And so now the kind of the meat of the problem is the algorithm for how do we determine that this string that we receive is all unique. And so the way I approach problems is you should always think of the brute force approach like first. It's not going to be the best, but once you have like a working solution, then you can kind of work towards a more optimal solution. So the brute force approach, I guess I'll go here, is if you had a string A, B, C, D, E, F, would be to loop over each character in the string. And then for each character, loop over the string again, except for the index that you're currently at. And then check if that character is anywhere else. So for example, how that would work would be, say you'd have like two characters you're looking at, say your current character and the character you're checking it against. So when we start off, it'd be, our first character would be A, and then we would skip A, go to B, that's not the same, all the way down the list, all the way to F. Then once we get to F, then we'll be able to iterate our current character. So then we'll move to B and then start from A and so forth. So that would be basically, you just put a, like it'd be like for like char and the string. Then this is just a pseudocode, like again, for like, I guess so I can match what I set up there. String. And then you would somehow need the index, and Python is pretty nice that you can use this thing called enumerate. And so the nice thing is with your outlines, you can make it as detailed as you want, or as minimal code as you want. But just so you can see that we have different indexes. Basically, I not equal to J. Then we could do check it if the current character is equal to the character we're trying to check, then you basically return false. And then if we go through all the characters in the string without finding a match, then we can return true. So this would be like kind of like one approach that you can take. And I'm not sure if people are familiar with big O notation or like runtime analysis, but I'll give you the quick version of how to tackle, or how to like define how long your code will take. So we use this thing called big O, which basically gives you an upper bound on how long your code would take for an input of size n. So since in this situation, we have what we call like a double for loop, where we're iterating over the input, not just one time, but for each character, we're iterating twice. So I guess that's a little confusing to explain. So say we didn't have this second for loop, and we're just iterating over each character. if we had an input of size n, or so for this case, it's input of size 6, we would have to check each of the 6 characters. So if we had an input of size 6, we would call that big O of size 6. But to generalize that to an input of size n, we would just call that O of n, like linear, like the y equals x. And so basically that shows like as our n gets bigger, our runtime proportionally gets longer, which is not bad. But for this, when we do this double for loop and we loop over our input twice for every index, it basically takes that n and then multiplies it by n because we're doing it twice. So that is n squared. So like y equals x squared, the parabola. And so as we approach infinity with our input size, our runtime will get basically approach infinity faster than the O of n. So this is kind of how we like kind of mathematically say like how long our code will run. And so O of n squared is not good. You typically want, the best is, let's try to go this way. O of n is like quicker than this. And then we also have, you don't have to worry about this yet. I think maybe next week we can go over what log n will look like. So log n is faster. And then the quickest we have is what we call C, or just a constant, like a number. Say like instead of having to loop through this whole string, like we can just receive the input and return something. So that would be like constant time. And so these are like the big like ways to quantify how quickly your code runs. And there's also, so this is called like runtime analysis. There's also storage analysis, but that's not too important. So if you had to do this problem and you wanted something to work, you could do this and it would work for most cases, but I'm not too familiar with how CodeQuest will test your code, but I think it's always good to think of the best, try and do the best solutions to your ability. So we want to reduce this O of n squared to something that would be quicker, because if they were to test this with how they would basically test your code is they would give it a really large string and then test how long it takes, and then they will know what your algorithm is if it takes n squared time, and then it'll fail. Not because you returned the wrong answer, but because it timed out. So the next thing we could think about, now that we have like kind of this outline, which is really much more coding, but it's hard for me to write it out in English and explain it. But I just want to make sure everybody understands, but it doesn't have to be like very like codey. So basically we want to avoid this double loop. So does anybody see like a linear way we could do this by avoiding this second loop? Or just a better solution in general? All right. There's this thing basically called like a sliding window. It's not really for this problem, but the way I like to imagine it is Let's just copy this. Very similar approach, but instead of this second for loop, we basically, so say we're at A, let's go through our example again. And see, this would be, I'm terrible at drawing, so I'm not going to try and draw for you all, but hopefully you can get the gist. Say we're in our first for loop and our current is equal to A. We can, let's think. I guess this is slightly faster, but I don't think it's not necessarily n squared, but say we have A, instead of looping through the whole our whole string again, we could start from our current index plus 1, because we know that all the characters before here have looked through the ones in front of it. And so if our current, say we're at D, and instead of starting from A to loop through to check if D is in the list, we already know that these characters before D have gone through and checked. So we know that D is not before it. So we can just loop through everything in front of it. So instead of starting at A, we would start at E. And so basically it'd be our double for loop again, but instead it would basically change where we start. So it'd be something like whatever, enumerate string, and then you could say like I or something. Not sure if that's the right syntax, but, and that would be slightly quicker than n squared. Aha, yes. Yeah. So that is actually the optimal solution that Marcus said. Thank you. But really quickly to end this one up, it would be something like O of n, I think it's times m, where like m is the length of the string, but it basically turns out to n squared. Actually, I don't know about that. Don't quote me on that. But still, double for loop is not good. So what Marcus is suggesting is to use a hash set at every index, and then return true if the hash set length is equal to the string length. Oh, sorry, I didn't see you sent that to me directly. But yeah. So basically, what we'd want to take advantage of is the hash or dictionary. And so dictionary basically, if you're not familiar, try to make some room. So a dictionary, you have keys, key value pairs. And so in our instance, say the character, we could have a dictionary of like characters. So we could have A as a key, and the value can be true if it's present. And so what Marcus is suggesting is basically if we add every character to the hash set, or the key difference between a set and a dictionary, well, at least in Python, these are the two names, but I'm guessing hash set is the same as set, is that you only have keys and every key is unique. So that key property we can use to leverage on this problem. And so basically, if you convert your input string into a set and compare the lengths of these two, you'd be able to determine whether it's all unique or not. And so this approach would still require our for loop. Let's see, what are we on? Okay. This one could be 0. This can be 2. So I'll try to write a more like English high level for loop. So loop over string. And then for each character, we'll basically say add to set. And then always you gotta initialize your set. Set to empty set. I can't spell either. Empty. That looks close enough. Initialize set to your empty set, and then add the character to the set. And then you can compare the length of the set and input string to return your results, which this is pretty good. This, since you have to loop over the string, or even if you like use built-in functions, they'll internally loop over the string. So you'll have something O of n, which is significantly faster for bigger input sizes. And the only thing I would say for this would be that in theory, you don't even have to loop over the whole string. Before adding the character to the set, you can first check if the character in the set, then you could return false. That'd be the only thing. And instead of having to do this comparison, which, real quick, if you say you have 2 for loops, like if I did this loop, it ended, and then I looped again over here. Instead of it being n squared, you basically take different operators and you add them. So it'd be n plus n. Instead of, when things are nested, you multiply them. And when they're not nested, you can add them. But O of n plus n is just equal to O of n. Because, sorry, this is like a very quick way to describe it. You'll learn a lot about this if you take a algorithms class, but O of n is still like the upper bound of O of n plus n, so we just call it O of n. But yeah, so that'd be the only modification to what Marcus was suggesting, is so that you can return early. But one thing to note, big O is you always define your runtime for your code in the worst case scenario. Because it wouldn't make sense, like if we were to say our best case, it'd be a empty string, it'd be O of 1 because we just check the size of the string, and it'd be 0 and we return true. So we always think of the worst case. How long would it take when our input is really large, or like of size n? So yeah, any questions? And so like this is like kind of like how I would go through. I'd first think of this brute force, like how do I literally like loop through the whole input string? And then once I see that I'm like doing the double for loops, not never good, but most times it's not that good, especially for like these kind of problems. Trying to optimize that a bit, trying to reduce the runtime, and then thinking about how can I leverage like the properties of some data structures that I know in order to get a quicker solution. And a lot of these times, if you see words like unique or like you got to count stuff, I would think of dictionaries and sets. So, but yeah, is there any questions? I guess if people want, they can try to code it, and then, but I think the most important part is understanding like the logic behind what you're coding. All right. I really only had one problem for today, but how about we still have 20 minutes? Is there, would you rather hear about like go through another problem together, or do you guys want to try do a problem of your own and then for like 10 minutes and then we can have somebody share and then give somebody feedback? I'm open for whatever. Okay. Oh, you know what? How about I just go over like how I would test? I feel like that could be kind of useful. Let's see. One second while I bring this up. I just have like a kind of like a code base of problems that I've worked on. And so like this was the first problem I found. Let's see. Okay. Share. Oh, shoot, not this one. This one. There we go. Oh, okay, never mind. Somebody, I'll do this real quick. So very similar. This top one is kind of the approach that we saw, but the main thing is basically you have your, if you write your routine that takes in the string and returns based on the result, you can just call that routine and then basically what I do is check, I'm expecting true. And so when this prints, if it returns true, the result would say true. And then this is like a quick and easy way to like just run your test multiple times. And like, say you have different ways to solve it, you can just click run one time and then it'll test for different scenarios, and you can have as many test cases as you want. But yes, how about we, everybody pick a problem from the CodeQuest site, and then at about 6:50 we can get back together and try, somebody can share and then they can try and talk through their process. All right, just message me if you have any questions. All right. I know that wasn't a lot of time, but would anybody like to share and go over the problem they tried to do or tried to start thinking about? Or is there any, I guess while we wait, would people like to, or was this too elementary or like basic, or was today good? Because I guess next week, or I guess in 2 weeks, uh, up to you all what we talk about. We can talk about something similar, like uh, maybe like sorting algorithms, uh, or like searching algorithms, or we can look into something a little more complex, like looking at uh, graphs or just more problems. Really up to you all. I'm pretty open to whatever. So cool. Okay. Well, it looks like we're all pretty good. Uh, let's have a good one. Or I think in the meantime, just do more problems and feel free to ask your teacher if you have any problems. They can forward it to me and I'll take a look. But yeah, I'll think of something.